Okay, I'm just waiting for the signal from they are recording the presentation. So it's okay to start now? Okay, great. Hello, welcome everyone here. My name is Gaetana Sapienza. I'm working as senior scientist for ABB Corporate Research here in Västerås, and I'm also a PhD student enrolled at ITSISI Research School here at Melbourne University. I'm here today to present the work that I have done during these 5-year studies. We titled Hardware Software Partitioning Methodology for Embedded Application Using Multi-Criteria Decision Analysis. I will start here to present the research context in which my study has been developed. I will discuss and present the research question that we have addressed here. I will continue to discussing the contribution, and then I will present the validation. I will list the publications that have been part of this work, and I will conclude my work and present some future directions. So let's start here to set the context in which the research has been performed. So we are talking about embedded application. Typically, embedded applications we are talking about, for instance, robot controller or a motor controller application for pump, for instance. And there is a trend today that is to deploy this application into the so-called heterogeneous platform, which are platforms consisting of more computational units, as for instance, FPGA and CPU and GPU. And assuming that we develop the application as a number of interconnected components, where components is an executable unit that can be independently deployed either on the hardware or other on the software, for instance, as HDL or C++ code. Here, there is one question, that is how to optimally distribute the components into the heterogeneous platform, as, for instance, HDL code or CPU code. This is well known as hardware software partitioning in the co-design community, and that has been research topic for more than over 20 years. So, when we develop embedded systems, we need to take into account many aspects. We need to take into account the functional requirements, the methodology that we are available, the technology that we have available, the non-functional requirements, and also the project business constraints. When it comes to this, I mean, we are for the purpose of our research, we are interested in the non-functional requirements and the project business constraints. Many of these aspects, they can be actually defined through the so-called X-functional properties, which are properties describing the quality characteristic of a system or a component. Traditional approach today when it comes to the partitioning are focused on the on aspects of extra-functional property related to, for instance, performance, related to resource utilization as FPGA area or memory, footprint, and power consumption. In our case, it's very important for us to, it's very important for us to take into account all possible consideration, all possible extra-functional properties that are important for the partitioning. Today we need to fulfill many requirements, and we want to see which one is the most suitable way to fulfill these requirements, considering many extra-functional properties related for the partitioning. Thus, our research problems consider that we have system as a number of components interconnected, and for each component we can have different implementation as hardware and software. If we combine all of these configuration, all of these components for each in the system, we will, assuming that we have n components, we will end up with several configurations. Like with n components, we will have 2 power on n possible configuration that can be deployed into the heterogeneous platform. And we have many constraints that we want to address, which constraints can be different, can be contradicting, can be conflicting. So this is a trade-off questions. So our research problem is which configuration is the best with respect to many extra functional property for the partitioning. So given the many configuration, given several extra functional properties, we want to see which is the best configuration with respect to the satisfaction of many extra functional property to be deployed into the heterogeneous platform. With this background in mind, this research problem, we said several research questions that are related to our problem. The first one is what will be a systematic decision problem to support engineering performing hardware software partitioning of embedded application, given the fact that we will several configurations and many extra functional properties. How this can be treated in a systematic way in order to support the design in performing the partitioning. The second research question is, okay, we have seen that we have many extra functional properties. Which of these extra functional properties are relevant for the partitioning? And in which way? So that is the second research question that our work has tried to address. And the third research question is, we are working with so many extra functional properties. We have a set of finite alternatives that we have to decide which one is the best one. And we have that this extra functional property can be of different kind. For instance, we can work with quantitative, we can work with qualitative, and they can be expressed using incommensurable units. So the question here is, what method and if exists related tool will be able to support us in performing the partitioning using so many extra functional properties. With this in mind, we provide here solutions which basic pillars are using a model-based design, which allows us to distinguish from component model and implementation of the same components, and allow us to switching independently at high level between the two technology, hardware or software. Then we apply component-based design because we want to formally define the components. So the variance means the implementation, the type of component you are working, and the extra functional property. And we want to do this one in a uniform way and automate the process. So for that one, we use component-based development technique. And as last, since we said that we want to deal with many extra functional property and infinite set of alternatives, we use multi-criterion decision analysis, which is a sub-discipline of operational research that provide methods that are able to perform a decision using many criteria in a structured and transparent way. So in our case, given the number of possible hardware software components, variant, and considering many extra functional properties, this method allows to prioritize these decision criteria, which correspond to the extra functional properties, in order to rank which is the best component that meet trade off all of the requirements that our application has to satisfy to meet the application goal, the development goal. And thus, the outcomes will be actually our solution to be deployed into the heterogeneous platform. For doing this one, we define multi-pair, which is the novel methodology that we are presenting here. And it is here in this slide detailed more through the process flow in order to systematically support designer in performing the partitioning. It is a bottom-up approach, so we start at component level. We considering actually the components and we analyze the components, and we take then, once we select which components, variants, and implementation are the best one, go to system level and perform the optimization at system level. we, in our process flow, the model is already there, so we know what are the components and the structure, the architecture of the embedded application. We consider several requirements from a different perspective, from the perspective of the application, from the perspective of the system, and we have available a library or repository of existing components. So consider all of these aspects. We start to define which components are important, are relevant for in our case. We identify which we want to take it. Then we continue by identify which extra functional properties are relevant in this, for these specific applications. We filter out components that are not relevant or they do not match actually the requirements. We continue to prioritize our decision criteria, which are more important, and we use multi-criteria decision analysis to select for each components the best two variants, the hardware variants and software variants. Once we have reached this phase and we are satisfied, we go ahead and basically we build all of the possible combination using these two variants for the system configuration. It might so if we have n components, we will have 2 power of n components. So we just decrease the design space with the first optimization done at the component level. We then continue. Some activities can also perform in parallel to identify the extra functional properties of interest at system level, which might be different compared to the one at the component level. We prioritize them. We calculate the extra functional properties for the system configurations. We continue to filter out the system configuration that might not satisfy the system requirements. We then perform the optimization, which will give us and will tell us which is the best hardware and software configuration that could be deployed into the heterogeneous platform. And last, we perform some activities to verify that this is result that we have achieved is the one that we were interested to have. We said that we have many extra functional properties and we work with components. So one question here that is part of relevant or important to support engineer is the formalization of how the components, how to treat the component. For doing this one, we define actually a meta model. So our system, we have consists of the platform plus the application. The application is consists of a number of interconnected components. For each component, we have the implementation that we call it variant. And for each variant, we have associated a number of extra functional properties. So we further actually specialize the extra functional properties in order to capture in a systematic and automatic way the difference between the hardware and the software extra functional properties. And we here propose a meta model of the extra functional properties in which the extra functional property is categorized and which value can have different different values expressed via different metrics and different format like integer, enumerative, string or distribution. And we then actually have a context in which we say that the extra functional property has to either measured, simulate or estimated. That's it was to help and support the designer in formally treat the components and to provide a meta model that is valid for different implementation hardware software. As a next step, we say in this case that we have the many properties and we want to see if they can be categorized and we want to see which are relevant for partitioning. So the next step in our case was to asking which extra functional property depends on the partitioning. For answering this question, we perform a survey in which we have different, we consider different source. We consider existing quality model. We consider the state of the art in partitioning, and we have several discussion interview with industry expert. Out of this one, we classify the extra functional properties of relevance for partitioning based in 3 categories. The first category is life cycle categories. The second one is runtime, and the third one is our project business related extra functional properties that are relevant, or they might be relevant for partitioning. Given the fact that we have this categorization, we have a lot of extra functional properties. The next question is, are these extra functional properties dependent on the type of partitioning? For doing this one, we formalize another question, and in order to answer in which way this extra functional property depends from partitioning. And we perform an interview, which interview was based on the 2 following questions. The first question, we want to check if the partitioning choice, for instance, if we select hardware or software, have a direct impact on the properties. And the second question was how we can assure, that if we want to implement this property, is it preferable to have an hardware or software solution, or is not relevant? So we perform an interview with the 15 person coming from the industry and from academy. We select persons that had more than 5 years of experience in the field, and we balance the pool of persons from industry and academy in this interview. We ask them this question in relation to the 3 categories that we have presented before: life cycle, runtime, and project business related. And here I'm just showing one example of the answer that we got it and the result related to the project business extra functional properties. And for the first question, we got that we had an agreement over 60% that project business extra functional property are relevant for the partitioning, which is new compared to the state of the art. And for the second question, if we want to achieve these properties, it's better to have a hardware solution, software solution, or it's not relevant. We actually get that answer that it doesn't matter if we implement a software, which this is good because then we can means that properties can be allowed to switch it between the 2 technologies we want to implement as hardware or software. And if we want to actually, for the one that they say is it important, they prefer the thing is easy to achieve if the implementation is done by software. Based on that one, so we say that we have now many functional properties, we categorize, we have our system. Our next step was, we are working with 2 levels, component level and system level. And we are saying that for system level, component level, we have a number of extra functional properties that we have identified. So the next question is, how can I support further the designer? Is it possible to derive at system level the extra functional properties using the information that I have at component level? So consider that we have our system. Our objective was, is it possible to calculate some of the extra functional properties using the information that we have already available at component level? In general, the answer is no, but considering embedded application, which have a very restricted constraint in relation to the execution, to the way how the communication is carried out between hardware and software, and between the components. We have a constraint on the platform, for instance, on the OS system that we are using. Then we were able to formalize a number of rules that allow us to calculate and derive the component properties the system property from the components. I just here present some example. One is related to the execution time, and we have, according now the components are executed, if they are executed in sequence or if they are executed in parallel, we were able to provide a number of rules that allow to considering the already existing information about the components and the values of the functional product at component level, and we were able to consider for this additional aspect as the communication time. Another example of this property is the total development cost, for instance, in which we were able to provide a formula that considered the individual cost of the components plus the cost of the total development environment used for develop the application plus the cost of the management for the project. Those are examples of rules that we have used and that we have provided for facilitated the designer in using applying multipar. Then we took another step further, which is related to which is the method that is suitable for performing the partitioning as multi-criterion method, because there are several methods and we want to check if this was applicable for our purpose and for our optimization. And for doing this one, we perform a survey and we look at an suitability analysis in which we look at the state of the art and the available method. We look into 37 methods and 22 tools. And the result out of this one, based on this analysis, with the support of experts, we have identified actually 11 suitability criteria to categorize if the method were suitable or no. And based on this one, we have performed actually the ranking of this method and tools, and we have that evidential reasoning was the most suitable, even though there is no method that we were able to fulfill all of the 11 suitability criteria. But with some modification, the method can be applied in our case. Based on this result, we were asking also which tool were available, and there are no tools that we can be directly applied for using multipart. Thus, we have implement a tool which is as the same approach, bottom-up approach that was shown in the process flow. So we start to define the component view, we define the extra functional property and the value of the property, and then at system level we are able to calculate also the apply the system rules that we have provided. This is already embedded, and we are able to ranking the best other software solutions, since there were no existing tool that we could be used. As next step, so we have done it, we have seen it, that we have defined multipar, we have checked which X functional property could be used. Then the next question was, is it how to validate the contribution that we propose, our work. And this has been based on one question from the feasibility point of view, which was, is the methodology that we propose multipar feasible for being applied in industrial applications. We use two industrial cases. One was the wind turbine application, the other one is the motor control application. And our strategy was based on demonstrate that the application, the solution achieved with multipar lead to solutions that are applicable and they can be run on real hardware. Then we want to compute the accuracy of the system rule that we propose. And for doing this one, we measure the values and we calculate the value and compare the result. When we use multi-criteria decision analysis and ranking the value, we get the ranking value. And we want to see if this ranking value was comparable with the ranking value that was achieved using measured value and calculated value. So we compare this as well. And as last part, we also perform a sensitivity analysis of multi-criteria method with respect to the weight factor, which play an important role in the selection of the final solutions. So if you look at the question if this is applicable, this is just the one of the example of the industrial case. We have used the motor control application, and we actually go through the entire process, and we were able to deploy the application on the real hardware, and we verify that one against the requirements that we have in our application, and we were able to run the brushless DC motor. The second part is related to the accuracy of the systems. So we want to check if the system composition rules were accurate enough. And for doing this one, we compare the measured values with the calculated values. We have done it this one for property that we could measure it at directly on the platform, like execution time, power consumption, memory footprint, and FPGA area utilization. And we saw that we have an accuracy that is above 99%. And we have also calculated the normal distribution, which you can see that we have a lower standard deviation for basically all of the four properties, which means that there are some deterministic error that can be eventually compensated via some offset. The last part related to the validation was to perform the sensitivity analysis. I take here two examples. One is related to the hardware property as execution time, and the other one is related to the system upgradability. In the graph, we have the weight value on the x-axis, which vary. The one that are indicated by the red line are the nominal value, and we vary the weight from a scale from 0 to 100. And on the y-axis, we have all of the variants that we were taking into account, the system configuration. The two that are marked with dashes, black line, are one, the number 80, which was the one that has been selected and be deployed as the best one, the most suitable one, while the number 1 is the full hardware configuration in which all of the components are implemented in VHDL. And we can see that if we look from the execution perspective, the one that has been selected has been always, even though there is a variation in weights, has been always the first one selected, while this is not the same things when it comes to system upgradability, because if we lower the system upgradability with the value lower than 30, we have that the systems is the two, then 80 variants is preferred to the variants that has been full hardware. And that is show that basically we are dependent approach from the weights assignment that we perform. That was related to the validation of the proposed methodology that we have discussed, in which we have proposed a new method that is able to select system variant, and is a bottom-up approach and allow taking into account many extra functional properties, and allow to get to select which one is the best hardware software configuration. This work has been presented in several publications, in 4 conferences and 1 journal, and 1 is technical report, which will be soon submitted as journal paper. These are the publications that are included in the PhD thesis. There has been other related publications that has been connected to this work, and here are just listed. We have some publications to journal and magazine, and we have some conferences and workshop publication, and 4 technical report. So that was related to the work that I have presented so far. So now if we considering what has been listened and presented today, there is multipart, which is a new methodology for the software partitioning of embedded application based on many extra functional properties. We have designed a process flow that is support engineering systematically performing the partitioning, considering many extra functional properties which can be conflicting, contradicting, and many compared to the existing approach. We have defined a meta-model that is uniformly allowed to treat hardware and software components in order to automate also the process. We provide a categorization of the extra functional properties that are of importance for the partitioning. We perform a suitability analysis of this, the impact that they can have it with respect to automation domain, which are relevant and how they are considered. We define a set of system composition rules in order to calculate the system functional property using the information of the component involved in order to facilitate this process. We also perform a suitability analysis on the multi-criteria decision method in order to be sure that we could apply that one for the partitioning to see to which extent. We implement a tool that is implementing multipart. We developed this one. And last, we validate the presented work through to industrial cases. If we think and conclude our work and we look at the different future possible research direction, the first one is related to the process flow, and we think that it's important to complement this process flow with activities that are able to capture stakeholder preferences in a more systematic way. If you look at from the perspective of the extra functional properties, we see that we need to further specialize the extra functional properties that are relevant for partitioning in other domains, as example, automotive or telecommunication, and considering other standards. We think that also is important to include a way to handle the non-functional property as safety and security in the process. And last, we want to further validate the efficiency of multi-part compared to the traditional approach, and we want to see if applying multi-part several times and enrich the library of existing components and back annotated all of the information, this can lead to more efficient and more effective way support the design in performing partitioning. That is everything, and thank you for your attention. I think we can move further with the next part.